Welcome to all in this lecture. In this lecture, I am going to discuss pile load test. Pile load test is very reliable method to calculate load carrying capacity of the pile. In this figure, you can see we consist two anchor pile and a reaction gutter provided horizontally that you can see in the figure. This is the reaction gutter. These two are the anchor pile, and we install a pile here, so we maintain the distance in between, clear distance between pile and anchor pile, that is 2.5 meter or 3b. Okay, we measure the settlement of pile with the reference of this reference mark. According to the reference mark, by using the dial gauge. So we set up the dial gauge here also, and by using the dial gauge we take the pile moment measurement. So when we apply the hydraulic jugs, by using the hydraulic jug, we apply some compressive load on this pile, and pile will settle in the soil. Okay, so this hydraulic jug is apply a load on this reaction also. So this reaction girder, due to help of this anchor pile, it's give the reaction, and due to this reaction, pile will get settled in the soil. And the pile settlement we measure or we calculate by using the dial gauge with the reference of according to this reference mark that we have shown here. This so this will not be shuttle, this will be fixed. Okay, so that it will give that relative moment of pile compared to this reference mark. Okay, then test is conducted after a test period of 3 days. So when we install this setup, so after that resting period of 3 days, for what? For sandy soil, and 1 month for silt or soft clay. So after completed this setup, we have to be leave for the leave it for 3 days in case of sandy soil, and for 1 month in case of silt or soft clay. Okay, so the load is applied in equal increment of 20% of the allowable load. So we apply in increment, and settlement can be recorded using the dial gauge reading. So each stage of loading is maintained till the rate of movement of the pile top is not more than 0.1 mm per hour, and in sandy soil, and 0.02 mm per hour in case of clayey soil, or maximum of 2 hours. So that is mentioned in the IS code 2911-1979. So under each load increment, settlement are observed at 0.5, 1, 2, 4, 8, 12, 16, 20, and 60 minutes. So the loading should be continue up to the twice of safe load. Okay, at which the total settlement reaches a specified value. So that I will show here. So once we applied a load up to maximum value, or up to the 2 times of safe load, so then what we will do? We will remove the load. So the load is removed in the same decrement at 1 hour interval, and we will measure also that while removing the load, what are the settlement were there. Okay, so रिमूव करते टाइम भी हमको सेटलमेंट देखना है, और बाई अप्लाइंग लोड उस टाइम भी हमको सेटलमेंट देखना है. ओके, and the final rebound is recorded 24 hours after the entire load has been removed. So that you will see here in the figure. So when we are applying a load, suppose we are applying a load, so we are getting the sum pile settlement, that is called that is called gross settlement. So when we are applying a load, so we are getting this settlement, right? Settlement due to this is the uh, curve between the load and settlement. Okay, so this is the gross settlement, we can say. Okay, so when we are removing the load, we are getting this one. We are getting this one. While removing load. Okay, unloading and loading. Okay, so you will see at the when you will remove the load, so there is some settlement, there is some permanent settlement. Okay, so you can see when load is maximum, it is here, settlement is here. When load is removed, settlement is there. So you will get at this point, you can say this is the elastic settlement. When we apply the load, settlement is there, and when you have just remove the load, settlement here only. Okay, settlement uh, settlement is up to here. So you will see this interval or this phase is called rebound. Rebound, but this is the value rebound for this load. For this load, suppose there is a load, suppose one condition. Okay, at somewhere else, suppose here you will see, suppose this is the second point. So at the second point, you will see the loading when we have done, we have uh, applied some load. So settlement is there, some settlement is there. Then we remove the load. Then you will see at this point settlement is this one. So you will get here also you will get, because final settlement when all load is removed, so settlement is up to this point. Okay, and when the load are there, so up to this point, so you will get this distance. So at the point two, at the second point, you will get the rebound, that is this one. So this is the rebound at second point. Okay. So now net settlement or net pile settlement we can calculate, that is SN. So that will be equal to gross settlement minus elastic settlement, or gross settlement minus rebound. Are you getting my point? Because this ST, so this is the gross and this is elastic. It means when you are applying load, so you are getting this settlement. When you unload, when you remove the load, so this settlement will be minus. This settlement will be recover, we can say. Okay, so that net settlement will be gross minus elastic. Okay, now according to IS 2911, and this is very important, how we will select what is the load carrying capacity of pile, how we will select the safe load. Okay, so this is very important. So there are three criteria. One, 2 by third of the final load at which the load settlement is 12 mm. Second condition, half to 2 by 3 of the load which gives a net settlement of 6 mm. Half of the load at which the load settlement is equal to 0.1 B, or we can for 0.075 B in case of under rim piles. So when the bale is provided at the base, or bulb is provided at the base, we can say that rim pile. So safe load will be minimum of 1 to 3. Okay, so these three criteria. So whatever the minimum load, that will be the safe load. So under the load twice the safe load, the net settlement should not be more than 20 mm or gross settlement should not be more than 25 mm. In figure you can see there is a two net settlement curve according to the with different soil condition. So you will see for the second condition that curve is smoothly going and is increasing. When the load is increasing, that net settlement will is increasing. But for the first case, at a certain point when load is increasing, that net settlement is not increasing, and we can say there is a sharp curve. Okay, so it depends what are the type of soil. According to that, you will get the net settlement curve. There are different types of pile settlement loads. Constant rate of penetration test. By name, you can get some idea that load on the pile we applied in such a way that the constant rate of penetration will maintain a constant. Okay, and that constant value will be 0.25 to 5 mm per minute. Okay, constant rate will be in this range. Routine load test. So by using this test, maximum load is limited to 1.5 times the safe load or up to the load which gives a total settlement of 12 mm. Cyclic load. So in this test, we perform this test to differentiate between the skin resistance and shaft resistance. So in this test, an increment load is repeatedly applied and removed in a cycle. Okay. Lateral load test. So in this, we perform this test to find out what are the lateral stability of pile, what are their capacity to take the lateral load. Okay, so this test is conducted to determine the safe lateral load on a pile. So in this case, by performing this test, we apply a lateral load on the pile. Okay, pull out test. So you have seen tension pile or anchor pile. That pile is resist tension load. So that kind of pile, we calculate or determine their uh, capacity by using the pull-out test. So in this pull-out test, we apply a tension load on the pile, and then we see all these criteria. Okay. So I will solve one numerical problem. A 30 centimeter diameter pile of the length 12 meter was subjected to a pile load test, and the following result were obtained. Determine the allowable load. So see, we are getting load is given, and according to that load, settlement during the loading is given. It means gross settlement is given in centimeter. Settlement during unloading is given. So what we can do, see, just make one graph. Sorry. So this is settlement, and this is load. Okay. This is settlement. Okay. So now I can make graph. This is the gross settlement graph. Okay. So and then here the this value settlement is 6 meter, 6 centimeters, 6 centimeter, and load is here 2500 kilonewton. Okay, then 6 centimeter. So now we are unloading. So we will get so unloading zeros at the settlement at this point is so 4 centimeter. You can see the table like this. Just draw a horizontal line so that you can get the rebound. So at this point, what is the rebound? So whatever the at that point, whatever this interval will be rebound, or we can say elastic settlement. Okay, so now we can calculate at this point where the load is zero, so you will get the zero rebound. At the load of 2500, you will get the See, at this point there is 4 centimeter, or this point there is a 6 centimeter. You will get 2 centimeter. Here you will get 0. So at a different load value, we can calculate the rebound. Okay, so at a 0 kilonewton load, so there is a rebound at 0 at the 500 kilonewton 0.6. Okay, up to, because see, 4 centimeter is at the 0 load, so whatever the increasing, so we can deduct the 4 centimeter, you will get the value of rebound. Now we have the rebound, means we have this elastic settlement. So by using the relation uh, gross settlement minus elastic settlement, we can get the net settlement. So in the next row, we can fill with the next net settlement, that is ST minus SE. Are you getting my point? So now we can draw the net settlement curve. So this is the net settlement curve. Okay. Now, so after the net settlement curve we draw, what are the three conditions? So we are writing all the three conditions. So the first condition was, I mentioned in the previous slide, 2 by third of load corresponding to what? Corresponding to a gross settlement of kitna mm? 12 mm. Means we have to take the value of load 2.5 of load corresponding to gross settlement of 12 mm. So see, when the gross settlement is, this is the curve, this is the curve for gross settlement. So when the gross settlement is 12 mm, say this is in centimeter, so 12 mm, so 12 mm means 1.2 centimeter. So it will come somewhere here. It will come somewhere here, right? So you have to take according to that what will be the corresponding, what will be the load. So you will see it will come somewhere here. So it is coming 70, 750. You can draw this graph in the scale paper. This graph paper, and you can see the exact value. So 750 kilonewton. So that will be 2 by 3 into 750. What will come? It will come 500 kilonewton. Now come to the second criteria. 2 by third of load corresponding to a net settlement. Net settlement of 6 mm. In centimeter, it would be 0.6 centimeter, 6 mm, right? So now we have to see, this is the curve for the net settlement. So you have to see on this curve. So when the 0.6, 6 mm, so what will be the load? So that you can see 0.6 mm somewhere here, and load will come somewhere here. So at this point, you will see the load, that is 1125 kilonewton. On the graph paper, you can get the exact value I am writing. Okay, so according to this net settlement 6 mm, we are getting load 1125. 2 by third into 1125, that is 750 kilonewton. What is the third criteria? Half of load corresponding to gross settlement. Gross settlement of 10% of B, or we can say 0.1 B, or we can say B by 10, whatever. Okay, so you have to see at gross settlement when B by 10. So what is the B by 10 value? So what is b by 10 value? B is given, that is B is given, we can see 30 centimeter. So uh, 30 centimeter divided by 10 means 3 centimeter. So we have to see the load for 3 centimeter. So for 3 centimeter load is coming on the gross settlement. This is the curve for the gross settlement. So it is coming 1700 kilonewton for 3 centimeter settlement, right? Okay. So half of the load. So half of the load will be half into what is the load? 1700. So it will come 850 kilonewton. So safe load will be minimum of these three. Okay, safe load will be, so safe load will be minimum of one, two, three. So what was the one? That is 500 kilonewton. What was the second? 750 kilonewton. What was the third? That is 850 kilonewton. Okay, so value will come 500 kilonewton. That is safe load or allowable load, we can say. So in this types of question, we have to draw net settlement curve, or according to all these three criteria, we can select from the graph what is the allowable load. These are the reference that I have taken. Thank you.